past, you have been mostly using degrees to measure angles. You might have seen radians before, but haven't used them that much. A radian is a measure of an angle that is used to measure angles just like we use degrees. Why do we need radians if we can use degrees? Radians give us more accurate values for angles, and they are smaller values so that they can be used to describe large or really small measures of angle. A radian is formed at the center of the circle by taking the radius on one side, radius on the other side, and then wrapping the radius around the circumference. And the angle formed here will equal 1 radian. So what does 1 radian equal to in degrees? In degrees, 1 radian is equal to approximately 57.2958 degrees. One complete rotation around the circle can be described in radians using the constant pi, 2 pi. Recognize it? Right, it's used in the circumference. Circumference of a circle is 2 pi r, right? So, one rotation, the angle at the center, 360 degrees, is 2 pi in radians. We don't really say 2 pi radians in writing. We just say 2 pi, and that means that the angle is in radians. So then, half of a rotation, or 180 degrees, is equal to just pi, and 90 degrees is equal to pi over 2. 270 degrees is equal to 3 pi over 2. And if we take half of 90, 45 degrees for example, then it's going to be pi over 4. You can label angles around the circle using radians, especially the angles that are frequently used and are well known, such as 30 degrees, 60 degrees, 45 degrees, 90, 180, 270, and 360. 0 will be 0 because it's at the start. At the start of what, will you say? Well, you can place your unit circle on a Cartesian plane. On a Cartesian plane, there will be a terminal arm, and when it's in a standard position, it rotates around the circle counterclockwise to form positive angles and clockwise to form negative angles. So then, when your arm is right on the positive x-axis, its measure is 0 degrees or 0 radians, or it's a complete rotation around the circle, or 2 pi radians. And you can make as many rotations as you like. You just keep adding 360 or 2 pi to your previous rotation. Then you move your terminal arm around the circle, and it forms an angle at the center each time. This one, that one, that one. And so we measure that angle and then decide how many radians or how many degrees that angle is. So the first one, for example, could be 30 degrees or pi over 6 radians. This one, 2/3 of 90, will be 60 degrees, or pi over 3 radians. The right angle is 90 degrees, or pi over 2 radians. And then if we add one more here, we're adding one more pi over 6. So this angle will be an angle of 120 degrees, or pi over 2 plus pi over 6. So you keep adding the 1/3 of a circle. Pi over 2 plus pi over 6 is equal to common denominator 6. Then this becomes 3 pi over 6, which is 4 pi over 6, or 2 pi over 3. And it is true. 60 degrees is pi over 3. 120 degrees is then 2 pi over 3s. What about this angle here? If we go all the way from the standard position to this angle, we're adding another 30 degrees, 150. And what is it going to be in radians? Let's see. So we'll add another pi over 6 to 2 pi over 3 now. And then that gives us 4 pi over 6 plus pi over 6 will be 5 pi over 6. We're just going to keep it that way. 5 pi over 6, which means we have 5 30-degree angles coming up here. And then another one will be 180 degrees, or just pi radians. And then you can keep going around the circle like that until you make it all the way to 2 pi, creating these special angles that are based on 30 and 60. There is another angle that we can form, and that angle could be half of 90, which is 45 degrees, or pi over 4. So when we create half of the quadrant here, we'll have 3 pi over 4. And then another one here will be, and then another one. So when a unit circle is on a Cartesian plane, it has a horizontal axis and a vertical axis, and it's divided into 4 quadrants. Quadrant 1 is a positive quadrant for x and for y. Both axes have positive values. Quadrant 2 has a positive y-axis but a negative x-axis. Quadrant 3. Both axes are negative. Quadrant 4. X is positive, y is negative. Why is that important? That is important because we can find ratios, trigonometric ratios for our angle within each unit circle. For example, if I have an angle that is equal to 30 degrees when built from the standard position, or we can also say it's pi over 6 in radians. Then we can see that a triangle can be formed, And that triangle will be one of the special angle triangles where we can use the relationship between the angle and the side length. One important thing though is that this angle that we create in quadrant 1 will be an acute angle. And we call it related acute angle. It's related acute angle because it will serve the basis for all other angles around the circle in other quadrants. For example, I can translate my 30-degree angle or pi over 6 angle here and form it based on the horizontal axis here. So this is also pi over 6. But because I have my principal angle coming from the positive x-axis, the principal angle will be this big one. So we call it principal angle. And the ratio of the principal angle will be the same numerical value as the ratio of the related acute angle. So this angle here, the principal angle, is 150 degrees, or it is 5 pi over 6. So the ratio sine of 5 pi over 6 is going to be equal to sine of just pi over 6. However, there will be changes in signs, positive and negative, for those ratios. So the numerical value will be the same, but the signs could be different. And it depends on which quadrant your angle is located in and what ratio of the angle you're trying to find. So in order to determine what quadrant the ratio is positive or negative in, we use something called the cast rule. So in quadrant 4, cosine ratio of the angle will be positive and the rest of the ratios will be negative. In quadrant 1, all ratios are positive: sine, cosine, and tangent. In quadrant 2, sine is positive, the other ratios are negative. In quadrant 3, tangent is positive, but the other ratios are negative. So CAST, the cast rule, tells you what ratio is positive in that particular quadrant. So now let's see how to determine those ratios. One of the triangles that could be formed inside the unit circle is the 30, 60, 90 triangle, or pi over 6, pi over 3, pi over 2. So pi over 6, pi over 3, and pi over 2. Based on the unit circle, the side length will be 1, 2, square root of 3 to 2. So when we try to determine the ratio of the angle, for example, pi over 6, pi over 6, and that ratio is sine of pi over 6. Then we're referring back to the special triangle and we say sine of pi over 6 will be opposite over hypotenuse, which is 1 over 2. And then if I have an angle here that is also based on pi over 6 related acute angle, but I'm looking for the principal angle, which is 150 degrees, or 5 pi over 6, then sine ratio of 5 pi over 6 will also be 1/2. What if I form an angle in the third quadrant based on pi over 6 again? I would have to go all the way down here for the principal angle. And now my angle is no longer 5 pi over 6, it's 7 pi over 6. And I can also see that in quadrant 3, only tangent has a positive ratio, but sine will be a negative ratio. So that means that sine of 7 pi over 6 will equal the same numerical value but a different sign. So negative 1 over 2. There is another special triangle, and that special triangle is based on 45, 45, 90 angle relationship, or pi over 4, pi over 4, pi over 2. And this side is 1, this one is also 1, and the hypotenuse is square root of 2. So if you have your 45-degree angle in your quadrant 1, and you translate it, for example, here, and you want to determine cosine of pi over 4. Cosine of pi over 4 will be 1 over square root of 2. And this angle in the second quadrant will be 1, 2, 3 pi over 4. In the second quadrant, cosine is negative because only sine ratio is positive. So cosine of 3 pi over 4 will be the same numerical value with a negative sign, negative 1 over square root of 2. You need to memorize these ratios, these relationships between the special angles, because a lot of the problems that you work with will be based on those angles. So say you're given the following expression and you want to evaluate it. In order to evaluate this expression, you need to first determine each ratio given the special angles, multiply them, and then find the sum of the products. So let's find each ratio. Sine of pi over 2. Let's think about it. Pi over 2 is an angle right on the y-axis at the top. It's a 90-degree angle. And on this angle, the radius is 1, and the distance from 0 to the top of the circle will be 1, which means the opposite side is 1. There is no adjacent side if I was trying to form a triangle because the angle is right on the y-axis, which means the adjacent side is 0. The hypotenuse, if I tried to form this triangle, would still also be 1. So the sine of a 90-degree angle, or of pi over 2, because it falls right onto the y-axis, is equal to 1. Next, cosine of 3 pi over 4. We can see that the angle 3 pi over 4 is based on one of the special angles, pi over 4. I'm going to use the special angle triangle, pi over 4, pi over 4, pi over 2. And the side length are 1, 1, square root of 2. So the ratio of the cosine will be 1 over square root of 2. But I also need to be careful with the sign. Based on the cast rule, CAST, my ratio could be negative. So which quadrant is 3 pi over 4 in? Pi over 4 is here in the first quadrant. Then there is another pi over 4 over there. And there will be one more pi over 4, the third one, over here. So it falls into the second quadrant. In the second quadrant, only sine is positive. So cosine ratio will be negative. Next, cosine of 7 pi over 4 is equal to, again, it's based on the same special triangle, pi over 4, pi over 4, pi over 2. So we're looking for cosine of pi over 4, which again is 1 over square root of 2. And then we need to locate where the 7 pi over 4 is. A complete rotation will be 8 pi over 4, because 8 pi over 4 can be reduced to 2 pi. So 7 pi over 4 will be 1 pi over 4 less. So like this, 7 pi over 4 will fall into the fourth quadrant where cosine is positive. So that gives us positive 1 over square root of 2. And the last value that we need to find, the last ratio, is tangent of 5 pi over 3. All right, pi over 3 is a different special angle triangle. So here we'll go pi over 6, pi over 3, and pi over 2. 1 square root of 3, 2. Tangent is opposite over adjacent. So square root of 3 is opposite to pi over 3, adjacent is 1. Square root of 3 over 1, or just square root of 3. Next, we need to establish where 5 pi over 3 is located, which quadrant. So then, 1 pi over 3 is here, 2 pi over 3 is here, 3 pi over 3 will be right here. It reduces to pi. Then 4 pi over 3 is here, and 5 pi over 3 will be right there in the fourth quadrant. In the fourth quadrant, tangent is negative, so we add the negative to our ratio. Now that we have all four values, we're now substituting each one of the expressions, each one of the ratios with their value. So sine of pi over 2 will be 1. Cosine of 3 pi over 4 is equal to negative 1 over square root of 2, plus cosine of 7 pi over 4 is 1 over positive square root of 2, and tangent of 5 pi over 3 is negative square root of 3. Let's multiply and then add. So then here we get negative 1 over square root of 2, and then plus negative square root of 3 over square root of 2. That means that we're adding two negatives with the same denominator. So then our final expression will be negative square root of 2, 1 plus square root of 3.